Alright, ladies and gentlemen, welcome back to Honors Theoretical Chemistry. Today we're going to talk a little bit more about the atom because we know that each element has its own unique properties, and this is because each element is its own special kind of atom. Now before we can describe atoms, we got to talk about how atoms are put together, just the structure of those atoms. So what are the forces that actually hold the nucleus together? There are in fact three nuclear forces that hold our nucleus together. And inside that nucleus, we know there's some protons and there's some neutrons that are all kind of stuck together, all smushed together. And there's three forces. There's a neutron-neutron force, there's a proton-proton force, and there's a proton-neutron force. And this all has to do with these funny little things called quarks that kind of hold and stick them all together, even though they shouldn't technically stick together, but they do. They hold all these atoms together. And these quarks come in six different kinds. There's an up quark, a down quark, a strange, a charm, a bottom, and top. I know that seems real goofy, but that's because of the way in which you described their relationship to one another. Now, we call electrons something a little bit different. Electrons we call leptons. Okay? Electrons, we sometimes call them leptons when we talk about their internal or inside structure. Okay? So these are the forces that hold our atoms together. Now, we got these protons in the center. They're positive. They're holding these electrons in these outside energy shells in place. And that's what makes our atom. Now, each atom has its own set of unique properties. And those properties come from how they're built. Inside each atom, we've got protons. Those protons create a positive charge. And based on the positive charge, we have a certain number of electrons, negative charges, held in balance. And there's a couple different ways in which we can write them. The first way we can start to write our elements is, we see this over on the side here, we call this a nuclear symbol, okay, where Z is the atomic number. And I think Dexter's laboratory, the atomic number. Z atomic number, Z atomic number. The atomic number is actually equal to the number of protons in an atom. So this is actually how we go about identifying our elements. We look at Z atomic number. And on the periodic table, which you now all have in your possession, on the periodic table, Z atomic number is equal to this top number. So for chromium, Z atomic number is 24. So we now know that chromium has 24 protons. It's that number right there off the periodic table. Z atomic number. Right? Nickel would have 28 protons. Titanium would have 22 protons. Calcium would have 20, and so on and so on and so on. Okay? So the atomic number equals the number of protons. All right, one second. Let me get back in here. Turn slide. Perfect. So Z is the atomic number, equals the number of protons in our atom. Not to be confused with A. The symbol A represents the mass number. A, I think of the fonts. A, mass number. A is the mass number. That is the total number of particles that give us mass. And we know from our research earlier this week that the electrons don't have a mass. The mass just comes from the protons added to the neutrons. So the total mass of an atom comes from the protons plus neutrons. Now I've heard in the past you've been given orders or you've been told to just round the mass from the periodic table. No. Because that number on the periodic table, that's completely different. Okay? To find the total mass, we either need to know the number of neutrons or we have to have been told the mass. We cannot take that number off the periodic table. And we're going to learn more about that actually in the coming week. Okay? So we do have these funny little things called isotopes. An isotope is an atom of the same element with a different mass. Now you'll notice over here on the side we have two C's. Now that C stands for carbon. We didn't talk about that. That X is the symbol. C over here is carbon. Here we have two atoms of carbon. One here, the top one is carbon 14. The bottom one is carbon 12. Now most carbon is carbon 12. This top one, carbon 14, is an isotope. It's still carbon. It's still going to have similar properties. However, it actually has a slightly different mass. It has actually two more mass particles. Now, bottom number, Z, is 6 and 6. We know it's the same number of protons. The only thing that's different are the number of neutrons. Okay? Again, an atom, general features of an atom is an electrically neutral sphere that's made up of a positively charged nucleus, made up of protons and neutrons, surrounded by the negatively charged electrons. Now, in the event that I've gone through this too quickly, you didn't get a chance to get everything down, that's fine. Go on back, rewatch it, pause it as much as you want. Okay? Feel free to change, do whatever you want. Now, I'd like to take a second. Let's work with some atoms. Let's do a little identification. Now, on Blackboard, you will all find a handout that looks like this, Atomic Structure Worksheet. Now, I'm going to ask that we fill this in electronically because we're just going to need to type in a few numbers. However, feel free to get a scratch paper to kind of follow along as we go, or have two windows, whatever works best for you. Now, our job is to figure out all these different pieces. Now, the symbol, if you remember from before, we give the symbol X. We represent the symbol of an atom using X. And that symbol for an element comes right off the periodic table. Now, there are a couple I want to point out that are kind of tricky. Sulfur is S. Sodium is Na. Right? Sodium is Na. Be on the lookout for that one. The other one that I've seen that gets tricky is potassium. Potassium is actually the symbol K, not P. P would be this wonderful element called phosphorus, which we need to live. We have phosphorus in our bodies. Okay? So, given the periodic table, we have, oh man, there's so much information here. It'll make your head spin, but that's okay. We're just introducing it today. We're going to learn more and more about the periodic table. We got a whole unit on periodic table. That's coming. Right now, we're just learning about our atoms and how we describe atoms, these building blocks of matter. So, if we look at the first one on our handout here, we're looking for boron. So we look around on boron, we look around on boron, well, there might be something that will help us. Here, we were told that the atomic number is 5. Oh, and the cool part is if you remember from our information just provided for us, the atomic number is equal to the number of protons. So right above the number of protons, I will go ahead and write the atomic number equals the number of protons. And we give protons the symbol P+. P because they're protons, plus because they're positive. Well, cool. We already know one of our boxes. If the atomic number is 5, we must have 5 protons. Ah, sweet. Already filling in it. Remember, mass. Hey, the bonds. Hey, the mass number. The mass comes from the protons added to the number of neutrons. Well, okay. We know the mass is 11. We're looking for neutrons. Well, 11 equals 5 protons plus something. Well, we can set that up. 11, the mass, equals the number of protons, in this case 5, plus number of neutrons. Well, do the opposite of what's shown. We're adding neutrons, so we're going to have to subtract out the 5. 11 minus 5 gives us 6 neutrons. Okay? Oh, we missed one. The symbol. Well, if we look, we know that elements on the periodic table are actually arranged by the atomic number. So if we can find number 5 on the periodic table, let's see, 1, 2, 3, 4, there it is, 5. Symbol for boron would be B. So we go ahead, write in our B. Cool. All that's left is the charge. Well, what particles, we talked about this earlier this week, we've got a couple particles that give us a charge in our atom. We've got a choice of 3. We've got protons, electrons, and neutrons. Okay? We give neutrons the symbol N with the naught because they don't have a charge. The 2 particles that have a charge are protons and electrons. And if you take the number of protons minus the number of electrons, you will get your charge. If those are our charged particle, charge will have to equal protons minus electrons. Well, we have 5 protons. We've got 2 electrons, so 5 minus 2 gives us a charge of 3. And in this case, it's a positive 3. Right? 3 plus. We actually call this an ion. An ion is any atom that has a charge. It's not a neutral element. Now, if it was neutral, we'd have 5 protons and we'd have 5 electrons. Well, this makes sense. We got 3 extra positives. So that means we got a 3 plus charge. Now, I do ask, this is kind of one of those pieces of science that's just kind of tradition. If you have a charge, bring that back and put that on your symbol. Right? Just so that everybody knows this boron has a charge. It's an ion. All right? Given what we've talked about here in the example here, if you want, feel free to come back and watch how we step through these. Go ahead and complete this handout for Monday. Right? The other item for homework is that on Monday we're actually going to be in the lab. You should have received a lab handout on your way in here today as well. If you would be so kind, go ahead and read it. I know, reading for the weekend. Oh, man. And then there's just a couple of pre-lab questions that I'd like for you to complete for Monday as well. Okay? Thanks for watching, and I hope you have a wonderful, wonderful weekend.